Okay, so once again, good day to each and every one of you. So for today's lesson is we will be discussing all about electrostatics. Okay, so here, before we proceed in defining the electric charge or electric, so the ancient Greeks discovered as early as 600 BC that after they rubbed amber with wool, now the amber could attract other objects. So we say that the amber has acquired a net electric charge or has become charged. So now the word electric is derived from the Greek word electron, meaning amber. So because of what happened during the early 600 BC, so they have discovered that after they rubbed the amber with wool, so the amber could now attract other objects, or it is now become charged. So that's why the electric word is derived from the Greek word electron, meaning amber. So now, if we also define electrostatics, when we say electrostatics, it is the interactions. It is the interactions between electric charges that are at rest, or nearly so. So when we say electro, meaning electric, and static means at rest. So that's why it is the interactions between electric charges that are at rest or nearly at rest. Okay, so now, here, diri na dayon tong famous na quote na we have two positive charges. Now we have two positive charges or two negative charges repel. So we have positive and positive will repel each other. We also have negative and negative na charge will repel also with each other. And then we have a positive charge and a negative charge will attract each other. So to simplify this quote, we have same charges repel, different charges attract. So two different charges will attract each other, and two the same charges will repel each other. Okay, so here we have some figures, figure 21.1 A, B, and C. So these are the experiments in electrostatics. So for letter A, as you can see here, it is an interaction between plastic rods rubbed on fur. So if plain lang plastic rods, they neither attract nor repel each other. So they don't have any charge at all. But once it is being rubbed in fur, but after being rubbed with fur, now the rods repel each other. So they acquired a negative charge. So both of these two plastic rods have negative charges. So that's why they will repel each other after being rubbed with fur. So again, same charges will repel each other. So for letter B, we also have the interaction between glass rods rubbed on silk. So again, these plain glass rods neither attract again nor repel each other. So once we rubbed this plastic glass rods here in silk, a plain glass rods, with silk, so the rods still repel each other. So these two glass rods acquired a positive charge. So since they both have positive charge, so still they will repel each other. So now, but for letter C, if we will put the plastic rods which has a negative katunang girab na with fur, so this rod or the plastic rod now acquired a negative charge. Now if we will place it with the glass rods na ato ang girab in silk, so which now acquired a positive charge, so these two rods have opposite charges, so they will attract each other. So the fur rubbed plastic rod and the silk rubbed glass rod attract each other because again they have two different charges. So also on the fur and the silk, each attracts the rod it rubbed. So here are some of the examples on electrostatics. Okay, so let's proceed. So, by the way, our structure of atoms can be described in terms of these three particles. So, I think we all know these three particles. It is very familiar to us ever since, I think, elementary or even high school. So, these three particles, we have the electron, we have the proton, and we have the neutron. So, electron is the negatively charged particle. The proton is the positively charged particle, and we have the neutron, which is the uncharged, or neither positive or negative. Okay, so we have the mass of the electron is 9.1093815, and then we have 45 times 10 to the power of negative 31 kilogram. The mass of proton is 1.6726216373 times 10 to the power of negative 27 kilogram, and we have the mass of the neutron is 1.674927211184 times 10 to the power of negative 27 kilogram. So as you can see here, out of these three particles, the electron is the lighter or the lightest of this among these three particles. So si electron ang pinaka gaan sa ilaatanan. Okay. So here, let's proceed with Coulomb's law. So Coulomb's law states that the magnitude of the electric force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So in mathematical terms, if you want to put that into an equation, we have the electric force, which is F, is equal to, it is directly proportional to the product of the charges. So we have Q1 and Q2 as our charges, and inversely proportional to the square of the distance, or we have divided by R squared. So again, where our F is the magnitude of the force, our Q1 and Q2 are our 2 point charges. We have K as our proportionality constant. So we will know later on what's the value of K. And then we have R is the distance between these 2 point charges. Okay. So since F is the magnitude of the force, so as you can see here, Q1 and Q2 is enclosed in an absolute value nga bar. So magnitude raman ta without the direction of the force. So that's why our product of Q1 and Q2 must be always positive. Okay. There are some cases na Q1 is negative or even Q2 is also negative. So whatever the sign here for the product of Q1 and Q2, since it is enclosed in an absolute value nga bar, so it is always positive. So the magnitude of the force is always positive. Okay. So how about for the value of the proportionality constant K? So we have now here the value of our K. K is equal to 8.987551787 times 10 to the power of 9 Newton times meter squared per Coulomb squared, or we can just have it as 8.988 times 10, round off lang nato to 8.988 times 10 to the power of 9 Newton per meter squared over Coulomb squared. Okay, so by the way, our units for this one, so our force, how about for the units before we proceed? So for the units, unit of force is in terms of Newton. We have our K, as we have seen earlier, is Newton per meter squared over Coulomb squared. Now, sa kinsa man ang Coulomb na unit. Okay. So, kaning si Coulomb na unit is the unit of our point charges. So, we have Q1 and Q2 Ang unit ana niya is capital letter C, which stands for Coulomb. And then for our R, we have in terms of meter. So those are the following units of our variables in Coulomb's law na equation. Okay, so let's go back. So here, again, this is the value. 8.988 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared. Okay. So now, equation 21.2 right here, as you can see, instead of K, we expressed it in terms of pi and epsilon naught. So we call this as epsilon naught, this one here. So, instead of K, we replace it by 1 over 4 pi epsilon naught. Okay, so can you see 1 over 4 pi epsilon naught is still equal to 8.988 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared. So this is the numerical value for 1 over 4 pi epsilon naught. So we have the value of epsilon naught, which is equal to 8.854 times 10 to the power of negative 12 Coulomb squared per Newton times meter squared. So here it is mentioned na in examples and problems, we will often use the approximate value. So instead of 8.988 times 10 to the power of positive 9, so it is rounded off to 9 times 10 to the power of 9. So see, 1 over 4 pi epsilon naught, or this is our value of K, is equal to 9 times 10 to the power of 9 Newton times meter squared over Coulomb squared. So it is much easier to memorize the value of K because it is rounded off to, instead of 8.988, so it is now 9 times 10. So we will be using this one in our problems and also examples. So atong gamito nga value is si 9 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared. Okay, so that is the value of our K, or si proportionality constant. Okay, so let's try solving some of these examples of Coulomb's law. So we have, this is the force between 2 point charges. So as you can see here on the figure, letter A, so we have the two charges, Q1 and Q2. Okay, so 2 point charges, Q1 is equal to positive 25 nano Coulomb. Okay, so what is nano, or pila ang value ni nano? So by the way, nano, let's say 1 nano Coulomb. So 1 nano Coulomb is equivalent to 1 times 10 to the power of negative 9 Coulomb. So meaning, si nano, this is a prefix. So we have 1 nano is equivalent to times 10 to the power of negative 9. So that is the equivalent of nano. Okay, diba? We have the different prefixes. We have kilo, centi, dc, and so on and so forth. So micro, those are the prefixes. So si nano is also a prefix, which has a value of times 10 to the power of negative 9. So kung nano Coulomb, it means na times 10 to the power of negative 9. So if we will rewrite Q1, so let's write the given values here. If we will rewrite Q1, Q1 is positive 25 nano Coulomb, or it is equal to positive 25 times 10 to the power of negative 9 Coulomb. So that is the value of our Q1. And then we have Q2 is negative 75 nano Coulomb, or it is negative 75 times 10 to the power of negative 9 Coulomb. So these 2 point charges are separated by a distance r. R is equal to 3 centimeters. So R is 3 centimeters. Okay, so before, we will not be using centimeters, but instead we will be using meter. or meters as our basic unit for the r, or the distance. So we will convert 3 centimeters into meter. So 3 centimeters is 3 divided by 100 is 0.03 in terms of meter. So this is 0.03 meter. So find the magnitude and direction. So we will find out the magnitude and the direction of the electric force. We have A and B. For letter A, we will find out the magnitude and direction of the electric force that Q1 exerts on Q2. And for letter B is we will find out the magnitude and the direction of the electric force that Q2 exerts on Q1. Okay, so let's proceed to letter A. So letter A is we will solve for the force that Q1 or 1 exerts on Q2. So using the Coulomb's law formula is we have K times, we have the absolute value of Q1 times Q2 divided by R squared. Okay, so here we have our K again. We have here is 9 times 10 to the power of, it is positive 9. Newton times meter squared over Coulomb squared times the absolute value. Don't forget the absolute value bar. Q1 is positive 25 times 10 to the power of negative 9 Coulomb times our Q2 is negative 75 times 10 to the power of negative 9 Coulomb. Again, the absolute value bar divided by R squared, or we have 0.03 meter quantity squared. Okay, so let's compute this one. So this is the force exerted by Q1 on Q2, or ang force nag-exert ni Q1 padulong kay Q2. Okay, so if you have calculators right there, you can join with me in calculating this one. So we have 9 times 10 to the power of negative 9, positive 9, sorry. Positive 9 and then multiply it with we have 25 times 10 to the power of negative 9 times negative 75 times 10 to the power of negative 9, then divided by 0.03 quantity squared. Okay, so the answer will be 0.01875. So it's now positive. Okay, again, it is enclosed in an absolute value bar. So this is negative if we will multiply this one without the absolute value bar. But since we have the absolute value bar here, so the answer for this one, or the product of this one, becomes positive. So the force that Q1 exerts on Q2 is equal to 0.01875. And then we have the unit Newton. So, anong Newton man? We have Coulomb times Coulomb. It becomes Coulomb squared. So, makancel out siya sa Coulomb squared here. Then this one, meter squared. So, makancel out si meter squared and the meter squared here. So, what is left is our Newton nga unit. Or we can also have it as, if we will round this off into 3 decimal places lang. So we have 0.019 Newton. So this will be our force that Q1 exerts on Q2. Okay, so remember this one. Okay, so how about the force that Q2 exerts sa magnitude sa taha later on at sa direction? How about the force that Q2 exerts on Q1? Okay, so let's have it here on the next slide. So force that Q2 exerts on Q1. So actually, the answer for this one is still the same. The same with letter A. So, ito lang ipakita. So, we have K times Q1 times Q2. Since product man si Q1 and Q2, or Q2 times Q1, so pwede ra siya mabali-bali. Okay, so let's erase this one. So, this is Q2 times Q1 divided by R squared. So, we have K, the value of K is 9 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared. Divide, we have absolute value of, we have negative 75 times 10 to the power of negative 9 Coulomb times positive 25 times 10 to the power of negative 9 Coulomb divided by 0.03 meter quantity square. So if we will calculate this one, we will still arrive on the same value with letter A, which is 0.01875 Newton, or we have 0.019 Newton. So meaning the magnitude of the force that Q1 exerts on Q2 is just equal to the force or the magnitude of the electric force that Q2 exerts on Q1. But here, diri na ta sa direction. So they are the same in magnitude, but let's find out the direction. Okay, so we have here on the figure, letter B is the free body diagram for charge Q2. So, ang direction daw ni Q2, or ang direction sa force that Q1 exerts on Q2 is going to the left. Now, why? So, notice na Q1 is a positively charged particle, Q2 is a negatively charged particle. So, what will happen here is, diba, two different charges attract each other. So, Q1, or ang force na gi-exert ni Q1 on Q2 is the attraction force. So, meaning, di-attract niya si Q2 padulong sa iya ha. So, that's why the direction of the force that Q1 exerts on Q2 is going to the left, or padulong siya kay Q1. Kay gi-attract man ni Q1 si Q2 padulong sa iya ha. So, that's why, again, the direction. So, if we will put the direction here, so for the direction, it is going to the negative x-axis. Okay. So, negative x-axis ang direction sa force. So, if we will rewrite this one with the magnitude and direction na, so we will put an arrow on top sa atong force, which indicates na it is now a vector quantity. So, the force that Q1 exerts on Q2 is equal to, we have 0.019 Newton on the negative x-axis. Okay, so this is now our final answer of the magnitude and the direction of the electric force that Q1, or nga gi-exert ni Q1 kay Q2. Okay, so now how about for letter B? The magnitude and the direction of the electric force that Q2 exerts on Q1, or ang force nga gi-exert ni Q2 padulong kay Q1. So as you can see here, the answer is on letter C. So this is the direction of the force that Q2 exerts on Q1, which is going to the right. Now, anong to the right man? Again, si Q2 ang nag-exert of force kay Q1. So again, it is an attraction force, meaning gi-attract ni Q2 si Q1 padulong sa iya ha. So that's why the direction is going to the right. Okay. So, kibali, or it is moving along the positive x-axis. So if we will rewrite this one, so vector force na ni siya, that Q2 exerts on Q1 is equal to 0.019 Newton along the positive x-axis. So this is the answer for the magnitude and the direction that Q2 exerts on Q1. So that is our example number 1, or our first example. Okay, so that is how we would solve for problems regarding with Coulomb's law along a along a straight line, or along one dimension, which is along the x-axis or horizontal. Okay, so let's try another example. So still along the x-axis lang gihapon siya. So we have here 2-point charges are located on the x-axis of a coordinate system. So we have Q1, which is equal to 1 nanocoulomb, is at positive 2 centimeters. So as you can see here, naadiri si Q1. So this is our Q1. Q2 is negative 3 nanocoulomb, which is at x is equal to positive 4 centimeters. So here is our Q2. So again, this is our Q1. This is our Q2. So mo ni ilang placement. So this is our diagram of the situation. Now the question here is, what is the total electric force exerted by Q1 and Q2 on a third charge, Q3, which is equal to 5 nanocoulombs at x equals 0. So si Q3 is na siya sa ato ang center, sa ato ang Cartesian plane, or at x is equal to 0. So nadiri si Q3. So ato daw ang kwaon ang total electric force nga gi-exert ni Q1 and Q2 kay Q3. Okay. So now, here is our free body diagram for Q3. So as you can see, if we will see the direction of Q1 exerts on Q3, so there is a repulsion. Okay, again, positive and positive. So they will repel with each other. Pero si Q2 and Q3, so if atong kuhaon ng force, or the direction of the force that Q2 exerts on Q3, so it will be a positive nga, I mean attraction nga force. So i-attract ni Q2 si Q3 going to the right. Okay. So that's why kani si F2, this is the force that Q2 exerts on Q3. So it is moving along the positive x-axis, whereas ang force nga gi-exert ni Q1 on Q3 is repulsion. So meaning i-repel niya si Q3. So ang direction ni Q3, or ang force, is going to the negative x-axis. Okay. So let's try solving this one. But before that is we will write all the given values provided by the problem. So we have Q1 here is 1 nanocoulomb, or again it is equal to 1 times 10 to the power of negative 9 coulomb. Our Q2 is, so Q1 is along the x is equal to positive 2 centimeters. Later on nata mag-convert kay x, ha. So Q2 is negative 3 nanocoulomb, or it is equal to negative 3 times 10 to the power of negative 9 coulomb. So it is along x is equal to positive 4 centimeters. And then we have Q3, our third charge, is equal to 5 nanocoulomb, or it is equal to 5 times 10 to the power of negative 9 coulomb at x is equal to 0. Okay. So what we will solve first is the force. Okay, kuhaan man na to ang total electric force. So we will get first the force, or solve first the force that Q1 exerts on Q3. So we have the equation for Coulomb's law, K times Q1 times Q3 divided by R squared, or R13 squared. So kini si R13 is the distance from Q1 to Q3, which is here located as 2 centimeters. Or if you will convert 2 centimeters, it is equal to 0.02. So this is 0.02 meters, and then 4 centimeters is 0.04 meter. Okay, so let's solve first this one. We have K is 9 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared. And then times, we have the absolute value. Q1 is 1 times 10 to the power of negative 9 Coulomb times Q3, which is 5 times 10 to the power of negative 9 Coulomb, divided by our R squared is again 0.02 meter quantity squared. Okay, so if we will calculate this one, so the force that Q1 exerts on Q3, so magnitude pa ni siya ha. So we have 9 times 10 to the power of positive 9 times, we have 1 times 10 to the power of negative 9 times 5 times 10 to the power of negative 9 divided by 0.02 quantity squared. So it is equal to 1.125. So if you have calculators, you can try in calculating this one and see if we will arrive at the same answer. So 1.125 times 10 to the power of negative 4 Newton. So this is the force that Q1 exerts on Q3. Okay, so let's try solving. So I will put this here. Force that Q2 exerts on Q3 na punta. So here we have K times, we have Q2 times Q3 divided by R23 squared. Okay, so here again we have 9 times 10 to the power of positive 9 Newton times meter squared over Coulomb squared, then divide times, we have Q2 is negative 3 times 10 to the power of negative 9 Coulomb times Q3 is 5 times 10 to the power of negative 9 Coulomb divided by our R is 4 centimeters or 0.04 meter quantity squared. Okay, so the force that Q2 exerts on Q3, so let's calculate this one. We have 9 times 10 to the power of positive 9 times, we have here negative 3 times 10 to the power of negative 9 times 5 times 10 to the power of negative 9 divided by 0.04 quantity squared. So again, it is a positive value, which is equal to 8.4375. So final answer na ta, mag round off sa ato ang answer ha. Times 10 to the power of negative 5 Newton. So we have now the forces that Q1 and Q2 exerts on Q3. Okay, now how about the direction of the force that Q1 exerts on Q3? So as you can see here in the free body diagram, this is the direction of the force that Q1 exerts on Q3. So girepel niya si Q3. So the direction of the force is going to the negative x-axis. So here, if we write it as a vector quantity, force that Q1 exerts on Q3 is equal to negative 1.125 times 10 to the power of negative 4 Newton. So the negative here signifies the direction of the force that Q1 exerts on Q3, or the repulsion no force or repulsive force. The direction of the force nga gi-exert kay Q1 on Q3. So this one right here. Or we can also have it as force that Q1 exerts on Q3 is equal to negative 1.125 times 10 to the power of negative 4 newtons. We have I hat. Okay, so if you can still remember, I hat is the unit vector for x-axis. So it means nga it is negative 1.125 times 10 to the power of negative 4 along the x-axis. So mo na siyang pasabot sa I hat. So this is again the unit vector for the x-axis. Okay. And then for the force, vector force that Q2 exerts on Q3. So as you can see here, this is the force that Q2 exerts on Q3, which is going to the right or along the positive x-axis. So it is still 8.43775 times 10 to the power of negative 5 Newton I hat or positive I hat. So positive man gyapon siya. So you can just put here positive if you want. So positive 8.4375 times 10 to the power of negative 5 Newton. Okay. So dili pa na mao atong final answer, but we need the total electric force. So total man. So total electric force, vector force na ni siya ha, on Q3. So the total electric force is the force that Q1 exerts on Q3 plus the force or the vector force that Q2 exerts on Q3. So this is our formula to solve for the total electric force. Okay. So F1 on 3 is, we have negative 1.125 times 10 to the power of negative 4 newtons I hat plus we have 8.4375 times 10 to the power of negative 5 newtons I hat. So both of them are I hat. Kaya again, they are along the x-axis man, or sila tulo are along the x-axis. So the total electric force or the total magnitude and direction of the electric force that Q1 and Q2 are exerting on Q3. So we have negative 1.125 times 10 to the power of negative 4 plus 8.4375 times 10 to the power of negative 5 is equal to, we have negative 2.8125 times 10 to the power of negative 5 newtons I hat, or we can just round it off to 2 decimal places. We have negative 2.81 times 10 to the power of negative 5 newtons I hat. So this is now the total electric force that Q1 and Q2 exerts on this third charge Q3, which is again equal to negative or 2.81 times 10 to the power of negative 5 newtons along the negative x-axis. So that is for our answer for the second example. So hope that you've learned something in our discussion for today, and we'll see you again on our next discussion. Thank you.